So this is the B4, C4, P4 higher past paper 1 run through. Remember, you always have these equations at the front of your paper to use, especially in the physics section. I'm going to start with the biology section. So first question is about food preservation. It says food preservation is important in hot countries. This is because food decays faster in warm conditions. Explain why. So any two of these, you can say that microbes can respire faster, microbes can reproduce or grow faster, and enzymes work faster, or enzymes are closer to optimum. So you have to use the word microbes or enzymes in each of those statements that I said to get any of those marks. Next question, humans treat food in different ways to stop decay. Some examples of traditional methods from hot countries are shown in the table. So we've got bumalo, which is from India. Fish are hung up in the open air for 5 days. Got black jang from South Africa, where apricots are put into pots with other fruit, water and sugar. And adobo from the Philippines, where meat is mixed with vinegar, garlic and bay leaves. It says draw lines to join each food with a method that is used to stop decay. So you need to get all of these correct to get this 1 mark. So fish being hung up in open air for 5 days, which is your bumalo, that's the same as drying the food. It stops the enzymes from working. Adobo, mixing with vinegar, is using acid, and then fruit, sugar and water is concentrated solution draws the water out of the microbes. So you need to link them up like that to get that 1 mark. Katie cuts 2 chips from a potato. She puts one of the chips into a test tube of distilled water. Katie puts the other chip into an empty test tube. Water enters the cells of the potato chip that has been left in distilled water by osmosis. Explain why. So 2 marks here. 1 for saying that the cells have partially permeable membrane, or a semi-permeable membrane, you could have said. And then the second mark saying that potato or cells are more concentrated than distilled water. You could have said, if you wanted for the second mark, that cells have a lower water concentration, or water moves from high water concentration to a low water concentration. You have to have a comparative remark there for that second point. Katie takes the potato chip out of the empty test tube. She measures how much it bends. To do this, she pins the chip to a cork. Katie then measures how much it bends using a protractor. Katie then measures how much the chip in distilled water bends. The chip that has been distilled water does not bend. Explain why. So 2 marks again here. So there's a couple of things you could say. You could say that the cells are full of water, or the cells are rigid, or the cells are swollen for a mark. You could have said the cells are turgid, or turgor pressure for a mark. Or you could have described turgor, so content of the cell pushing against the cell wall. Or you could have said the chip is turgid, if you wanted to, rather than potato. Katie repeats her experiment but puts potato chips in different concentrations of sugar solution. Look at the graph, and there's a few graphs there showing how much the potato chip bends with how concentrated the sugar solution is, and there's 4 different potato chips there. It says write down the letter of the graph that shows Katie's expected results. So that is this graph here, graph A. So this next question here is the 6-mark question, so please can you mark this yourself and then ask your teacher to check your marking if you're unsure whether it is correct or not, but make sure you try yourself first. A scientist investigates glucose production in swede plants. He looks at 5 processes A to E which are involved in sugar production. He finds out how energy is lost in each process. So you've got the processes here and how energy is lost on this side. And it says which of the processes A, B, C, D or E produces oxygen gas. So that is C here, where the water molecules are split. And how does the structure of a plant leaf help to reduce the loss in process A? So in process A, you've got sunlight hits chloroplasts in cells and swede leaves. So the cells with the most chloroplasts, or the palisade layer, if you want to put it that way, is near the top of the leaf. So that's how the structure of a plant leaf helps to reduce the loss in process A. Most of the chloroplasts are in the top of the leaf. Carotene xanthophyll help to reduce the energy loss in process B. Explain how to do this. So process B is light as absorbed by photosynthetic pigments. So 2 marks here, one for saying that they absorb different wavelengths to chlorophyll, and then the second mark saying that a wider range of wavelengths can be absorbed, or more of the spectrum is absorbed, rather than just the wavelength that chlorophyll absorbs. You could also have said that they absorb different colours of light, but you've got to have the first point talking about they absorb different wavelengths, and the second point saying that therefore a wider range of wavelengths is absorbed. Next question, so carbon dioxide and water are needed for photosynthesis. Finish the balanced symbol equation of photosynthesis. So this is just something you need to remember, that glucose is C6H12O6, and then it also makes oxygen, and then to balance, to finish it, you're going to need 6 oxygens. These two things could obviously be written the other way around if you wanted to. In 1649, scientists thought that plants grew by only taking in solid materials from the soil. A scientist called Van Helmont did an experiment to test this idea. He grew a tree in a large pot of soil. He measured the mass of the soil on the tree before the experiment. He measured them again 5 years later. Explain how Van Helmont's experiment proved the scientists wrong. So the first mark is for it doesn't matter how you put it, but the idea that there's not enough mass or materials or substances or nutrients lost from the soil to supply the mass, material, substances or nutrients gained by the tree. So you can see that at the beginning there's 100 kilograms of soil and 2 kilograms of tree, but at the end there's 99 kilograms of soil and 80 kilograms of tree. So these two masses add up to more than these two masses. And then the second mark is for showing the calculation. So the soil has lost 1 kilogram, but the tree has gained 78 kilograms. So clearly the scientists are wrong. Van Helmont wanted to find out if the tree gained mass from water. He watered the soil during the experiment. He covered the soil so that water could not evaporate from the soil. The mass of the water that he added during the 5 years was much more than the increase in mass of the plant. Suggest why. So this is the idea that water is lost in transpiration, or that it's evaporated from the plant. That's the first mark. And the second mark is saying that only a small proportion is used in photosynthesis. He needed to water the soil much more on windy days. Explain why. So there's more transpiration, or there's more water lost through the stomata, or there's more evaporation. Any of those get you the first mark. And then the second mark saying the wind moves away the water vapour. So we're on to the chemistry section now. So first question, atoms contain electrons, neutrons and protons. Look at the table, it shows the number of electrons, neutrons and protons in some atoms and ions. It says complete the table. So you've got to find out what atom or ion this is first, here. So you can do that based on the number of protons. Remember, the number of protons is what the atom is based on. And you can see that the one before had 15 protons. This is going to be the same element. So you're going to have P, and you're going to have 15. You've got the same number of electrons, so it hasn't got a charge, but you've got one more neutron. That means your mass number is going to be 1 greater, so you need 32 at the top. And then the number of electrons that this sulfur will have, well, it's got a 2 minus charge, so it's going to have 2 more electrons than the number of protons it's got. So if you put 18 there, that gets you the mark. This type of hydrogen and this type of hydrogen are isotopes of hydrogen. What is meant by the term isotopes? Only 1 mark here. So this is the fact that they have the same number of protons but different numbers of neutrons. You need both of those things to get the mark. In 1808, a scientist named Dalton published his atomic theory. About a century later, a scientist called Rutherford published another atomic theory. Why is it important that scientists publish their theories? So there's 2 marks here, so any 2 of these, so results can be replicated, or so work does not need to be duplicated. So further evidence can be collected, or work can be developed further. So you can check the work, or the work can be evaluated to provide information to other scientists or the public or other organisations. Also the information can be used by other scientists. Also he can get recognition for his work so that other scientists can't take credit. So any 2 of those will get you those 2 marks. Element X has the electronic structure 2882. Explain how you can tell that element X is calcium. So this is the idea that you can add up the number of electrons, and this will add up to the number of protons, and then you can check that on the periodic table. So it has 20 electrons, and on periodic table the element number of 20 is calcium. So any sort of explanation that this adds up to the number of electrons that calcium has, 20, will get you that mark. Chlorine has the electronic structure 287. Chlorine is a covalent molecule. Use a dot and cross model to describe the bonding in a molecule of chlorine. You only need to draw the outer shell electrons. So you can see the outer shell has 7 electrons. Now chlorine is a covalent molecule. It tells you that. So that's where the electrons are shared. So we just need to draw 2 circles, one for each outer shell of each of the chlorines, overlapped. And in that overlap, you'll have a dot and a cross. So I drew those opposite way around of when I was saying them. So a cross and a dot. And then you just need to fill in the rest so that they both have 8 electrons each. And then it might be worthwhile just putting Cl in the middle of them. So you got the first mark for having a shared pair of electrons here, regardless of what you put around here. And then the second mark is for the rest of these to be correct. Sodium chloride, NaCl, contains sodium ions, Na+, and chloride ions, Cl-. Explain why sodium ions are positively charged and chloride ions are negatively charged. There's 2 marks here. So the first mark saying that sodium loses electrons, and the second mark saying that chlorine gains electrons. Chlorine reacts with sodium bromide solution. Look at the ionic equation for this reaction. Explain why chlorine is reduced in this reaction. So the idea of oxidation and reduction, got to remember the term oil rig. So oxidation is loss of electrons, reduction is gain of electrons. So all you've got to put here is that the chlorine molecule gains electrons. So the chlorine molecule gains electrons in this. Now if you didn't know that from the formula, at least you could work it out from the word that's being used. So remember oil rig, oxidation is loss, reduction is gain. Chlorine also reacts with potassium iodide solution, Ki. Iodine and potassium chloride are made. Construct a balanced symbol equation for this reaction. So it says chlorine reacts with potassium iodide, which it gives the symbol for, and it tells you that iodine and potassium chloride are made. And then you've got to balance this, so that gets you 1 mark just for writing those out, and then these 2 numbers gets you the second mark. So this next question is the 6-mark question. Please can you mark this yourself, then ask your teacher to check your marking if you're unsure whether you've marked it correctly. Oscar has 4 beakers containing different solids. He dissolves each solid in water to make a solution. He tests each solution and records the results in a table. So you've got the reaction with barium chloride, silver nitrate and sodium hydroxide. Oscar makes a conclusion. One of the solids is a mixture of 2 compounds. Which solid was a mixture of 2 compounds? Explain how Oscar came to this conclusion. So, the first mark is choosing the correct one, and it is D. So D gets your mark, and then the reason is that it contains a sulfate because of the white precipitate with barium chloride, and it contains a chloride because of the white precipitate with silver nitrate. This colour is not important because that is a different sort of ion that will be in there. So you may have copper sulfate and copper chloride in here. So it's these 2 that are important. So if you chose D, that's your first mark, then saying that a sulfate must be there because of the white precipitate with barium chloride, and then a chloride must be there because of the white precipitate with silver nitrate. Those are your other 2 marks. Most metals have high melting points. Look at the graph, it shows the melting points of some metals. Write the symbol of the metal which has the weakest metallic bonds. So that's going to be the one with the lowest melting point. So that's this one here, which is potassium. But it just asks for the symbol, so it's K. If you wrote potassium, though, that will get you the mark. Describe using a label diagram what is meant by metallic bonding. So this is, you could draw a diagram like this. Remember, these are all positively charged. And then you could draw electrons in the middle. And the 2 marks here are first saying that there's an attraction between the positive ions and the electrons, and the second mark is for saying that there's delocalized electrons. So there's positive ions, delocalized electrons, and there's an attraction between them. So if you put something like this, that'll get you the 2 marks. So now on to the physics section. First question in the physics section says, ultrasound is a longitudinal wave. Look at the diagram of an ultrasound wave in air. Use a diagram to describe the differences between a region of compression and a region of rarefaction. So the first mark is saying that compression is a region of high pressure, or a region where air particles are close together, and rarefaction is a region of low pressure, or a region where air particles are further apart. So here's your rarefaction and here's your compression. If you said compression is where the lines are close together and rarefaction is where the lines are further apart, that will also get you both marks. If you simply labelled this diagram with the correct regions, that will only get you 1 of those 2 marks. Ultrasound can be used to scan the kidney and to break down kidney stones. Explain how ultrasound breaks down kidney stones. So this is the idea that ultrasound causes vibrations in the stone. So if you said vibrations or oscillations in the stone, that you get that mark. Explain why ultrasound is used rather than X-rays to scan the kidney. So this is able to produce images or scans of soft tissue, or it does not damage the cells or the tissue. Any of those will get you that mark. Now this next question is a 6-mark question, so please can you mark this yourself using the mark scheme that's on the Blue Coat Science Google site, and then ask your teacher if you're unsure whether you've marked it correctly just to check it over for you. Radioactive substances decay naturally. Look at the information about 2 different radioactive substances. Use the data in the table to compare the half-life of substance X and the half-life of substance Y. So first thing is to say how long the half-lives are. So the half-life of Y is about 1 hour. You can see that it's halved there and halved there and halved there approximately. And the half-life of X is about 4 hours. So if you look here, its half-life is about there, and then again around there. So 4 hours for X and 1 hour for Y will get you 2 marks, and those are what the 2 marks are for. Just working out the half-lives. Ronin and Kiri use an electric circuit to investigate the resistance of a thin wire. Ronin changes the length of the wire, he calculates the resistance for each length, but he plots a graph of his results. Calculate the current for a 1 metre length of wire when the voltage across it is 0.75 volts. So the first thing you need to do here is extend the line. So you've got to get your ruler and just extend it further up using a ruler, obviously. I can't really use one on my iPad. Then you need to look up the resistance in ohms for the length of wire. Now the reason why you've got to do that is if you look at the front page of this, you'll find that V equals IR, so voltage equals current times distance. So if you want the current, that's going to equal V over R. So that's going to equal 0.75 divided by whatever you read off the graph. So that's going to be around 5.5. So that equals, my calculation equals 0.14. Now actually, anything between 0.144 and 0.156 will get you the mark. It's because my line is so badly drawn. If you draw it straight, apparently according to the mark scheme, it should come out around 5 as your resistance. The voltage across the thin wire is kept fixed at 0.75 volts. Describe the relationship between the current in the thin wire and its length. So as the length increases, the current reduces, or the current decreases. So that'll get you that 1 mark. Then Kiri repeats the investigation with a thinner wire. She keeps all the other factors the same. Draw a line on the graph to show how the resistance of a thinner wire changes as the length increases. So I'll just draw it down, a rough sketch of the graph that we've already got. So this is the original line, and as long as you drew a straight line with a steeper gradient, so anywhere above this line, that will get you the mark there. This question is about nuclear energy. Complete the crossword. In stars, fusion happens at extremely high what? So the first mark is for temperatures. In fact, I'll go and do it on the crossword. So temperatures is your first one. And then nuclei of hydrogen isotopes undergo fusion to form what nuclei? So that's helium. Scientists stop nuclear fission reactions go out of control in a reactor by absorbing some of the what? That's neutrons. And then scientists stop nuclear reactions going out of control by placing metal what in the reactor? That's metal rods. So if you got all four correct, that's 2 marks. 2 or 3, that's 1 mark. And 0 or 1, that's no marks, I'm afraid. Andrea Rossi claims to have invented an energy catalyzer coal fusion system. He demonstrated the system in January 2011 by passing hydrogen over a secret catalyst. It appeared to show that an input of a few hundred kilowatts produced an output of a few thousand kilowatts. Some scientists believe that there is a nuclear reaction taking place because of the large amounts of extra energy produced. Suggests why other scientists might not accept this claim. So anything from these, so you can say there's no data or no evidence, or not all the data was published. You could say that there's secrecy, i.e. there's a secret catalyst. You could say that it can't be proved or reproduced or can't get similar or reliable results. And you could say that it disagrees with fundamental physics, as in fusion needs high temperatures or pressure that won't happen at low temperatures, so it disagrees with the fundamentals of physics. So any 2 of those 4 will get you that mark. Then finally, Tanida jumps up and down on a trampoline. The jumping surface of the trampoline is an insulating material. Tanida is wearing synthetic stocks. When Tanida gets off the trampoline, she gets an electrostatic shock as she touches the ground. Use ideas about electron transfer to explain why this happens. So 2 marks here, 1 for saying that electrons move between 2 insulators, or the electrons move between the socks and the trampoline. That gets you your first mark. You have to use the word electrons there. And then second mark is saying that the electrons flow through the girl to or from the ground or earth. That's your second mark. Anti-static sprays reduce the problem of static electricity on the trampoline. Explain how. So 2 mark again. So this is the first mark, is the idea that anti-static sprays leave a conducting layer or a conducting coating of material, or enables the trampoline to conduct. That's the first mark. And the second mark is saying that so charge can't build up, or so it can't store electrons, or static charge can't build up. So add up your marks, add it to your poster, and then have a go at the next paper, please.